The James Webb Space Telescope is once again showing off its muscles. While the most powerful space telescope ever built is homing in on the deepest secrets of the cosmos, it's also providing us with spectacular images that show us the structures of the universe in unprecedented detail. And although the formations are sometimes several million light-years away from Earth, the razor-sharp Webb images make them appear as close as your fingertips. However, the first spectacular snapshot of our video shows that the technically aided view of the stars can also bring some unusual, not to say strange, objects to light. Because if you ask us, Webb has captured a glowing penguin and its egg in the vastness of space. But if you ask an astronomer, they will explain that the image shows the pair of galaxies ARP-142, which are about 326 million light-years away and have been performing a close dance in space for quite some time. Located in the constellation of Ayla, the two galaxies have been merging for between 25 and 75 million years. It is a fate that is known to await our Milky Way and the Andromeda Galaxy in a few billion years' time. However, in the case of ARP-142, we are not dealing with two spiral galaxies, but with an elliptical and an irregular galaxy. As the name suggests, the latter are known for having neither symmetries nor clear structures. What is clear, however, are the impressive tidal arms that the irregular galaxy NGC 2936 has formed as a result of its interaction with its partner NGC 2937. There is a good reason why Webb's false color image in the near to mid-infrared makes it appear as if NGC 2936 is throwing cosmic confetti around. The colossal gas and dust clouds are actually accompanied by a high rate of star formation that significantly exceeds that of the Milky Way. In our home galaxy, about 6 to 7 new stars see the light of day each year, but in the case of NGC 2936, there are as many as 200 new stellar births every year. But before the irregular penguin can embrace its elliptical egg, which consists mainly of older stars and significantly less dust and gas, a little patience is still required. The distance between the galactic pair is currently around 100,000 light-years, which roughly corresponds to the diameter of the Milky Way. It will take several 100 million years before the two structures merge into a new galactic world. A combined view of the pillars of creation is also impressive. The photos of the breathtaking pillars of creation are not new in and of themselves. The Hubble telescope actually captured the gigantic star forge on camera back in 1995. More precise images by other telescopes followed in 2007 and 2011 before Hubble returned to the structure in the Eagle Nebula, some 7,000 light-years away, in 2015. Yet none of these images comes close to the ones Webb presented to the amazed public in 2022. Our new eye in space reveals even those structures in all their facets that appeared completely invisible in the images of its predecessors. While the newly forming protostars present themselves as reddish balls at the ends of the pillars, the curved lava-like lines represent nothing more than the rays that the young stars and their cocoons regularly hurl at the surrounding cloud material. However, the new combined view of the pillars of creation, published by NASA a few weeks ago, shows us that we should by no means put the Hubble images on the back burner just yet. Presented both in photographic and video form, Webb's infrared data shows the young stars and cool gases, while the Hubble images show the glowing hot gas components of the stellar cradle in visible light. The king of our planetary system is also shown in a new light. While Webb is best known for tracking down the most remote and thus oldest structures in the observable universe, we should not forget that from time to time it also takes a look at our immediate planetary neighborhood. How novel the view of the familiar can be is shown by the fascinating images of Jupiter, which show the king of our planetary system in a light never seen before, and that is meant quite literally. The human eye would not be able to perceive the details made visible by Webb. To remove our natural blinders, Webb's NIRCam captured the light reflected by the gas giant using 3 different filters. In this way, the infrared radiation from different wavelength ranges can be evaluated and displayed separately. Since infrared radiation is not visible, the corresponding wavelength ranges were then translated into visible colors. Even the most experienced experts were deeply impressed by the overwhelming level of detail. The Webb images show not only well-known structures such as the auroras or the Great Red Spot but also the delicate ring system, which can usually only be glimpsed, and the tiny moons of Amalthea and Adraste. Jupiter, with its diameter of 140,000 kilometers, is so massive that Earth would fit inside it over 1,300 times. However, if we let our gaze wander 12 light-years further to the star system Epsilon Indi, we find objects that make even Jupiter look small. Specifically, the exoplanet Epsilon Indi b has a mass 6 times greater than that of the largest planet in the solar system. The exoplanet Epsilon Indi b has a mass that is 6 times greater than that of the largest planet in the solar system, but that's not all. In the same breath, this alien world also embodies the coldest and oldest exoplanet that has been directly imaged so far. In principle, there are very few direct images of exoplanets to date, and most of them show young, hot gas giants which can be seen in the infrared as relatively bright points of light. Furthermore, the approximately 25 exoplanets captured directly to date were all younger than 500 million years, with a majority of them even younger than 100 million years. The situation is quite different in the case of the cold superjupiter Epsilon Indi b, which has actually existed for about 3.5 billion years. Researchers now hope to use it to test models of planetary evolution and clarify open questions about the late phases of exoplanets. What remains after a star's death? Supernovae are undoubtedly among the most powerful spectacles the universe has to offer. As soon as a massive star reaches the end of its life cycle, it collapses and bids farewell to the cosmic stage in a violent explosion. What the field of debris after such a stellar death looks like in detail is now shown by the Webb image, which was taken a few months ago in the constellation Cassiopeia. More precisely, we are dealing here with a high-resolution near-infrared view of the supernova remnant Cassiopeia A, which bears witness to an event that occurred around 340 years ago. Since the stellar debris is relatively close to Earth, the structure of glowing gases and a central neutron star is one of the most studied supernova remnants of all. While Cassiopeia A has already been examined by Hubble and the Chandra X-ray Observatory in the past, Webb's NIRCam made visible the filaments that the star left behind in its explosive demise in 1680. The inner shell of the structure, which consists of sulfur, oxygen, neon, and argon among other elements, can be seen in bright orange and pale pink. Outside the inner shell, we again see a kind of white glow, which has a smoke-like structure and marks the point where the supernova shock wave enters the surrounding circumstellar material. In this regard, scientists assume that the bright glow is due to light from synchrotron radiation, that is, light from charged particles spiraling around magnetic field lines at extreme speeds. And if you like, something like a prospective supernova is slumbering at the lower right edge of the image. Named Baby Cassiopeia, it's probably a glowing dust field that was only captured and heated by the shockwave long after the stellar explosion. Although it appears in the image as if the structure is directly next to Cassiopeia A, it is actually around 170 light-years away from the supernova remnant. The Serpent's Nebula has never been so detailed. Many a glittering family photo also comes with exciting insight. While the James Webb Space Telescope recently revealed completely new details in the Serpent's Nebula, 1,300 light-years away, it also provided astronomers with a crucial clue to a special characteristic of young stars. The bottom line is that experts identified a group of so-called protostellar outflow jets in this young stellar nursery, gas jets that emanate from newborn stars and interact with the surrounding gas and dust. Normally, these outflows point in different directions, but in this case, they all point in the same direction, from the top left to the bottom right. This fact, in turn, supports the thesis of some researchers that young stars tend to rotate in the same direction when their gaseous birthplaces collapse. The reason why experts have only now detected this particular detail of the Serpent's Nebula is quite simple. In previous images, the flame-like structures appeared as blurred spots or were even completely invisible. Fortunately, Webb's high-resolution NIRCam is able to penetrate the cosmic dust and gas clouds, making the optical barriers of the past a thing of the past.